breathe deeply and get into trance. Shanti, Shanti. I'll take you to the seventh heaven. Through meditation, don't have any other thoughts in your mind about seventh heaven. I'm just wondering who is going to get my presentation. Now I need some peace, inner peace. Inner peace. Has anybody watched Kung Fu Panda? Okay, here I am, hopefully. Thank you so much. And before we start, do you have any questions on spirituality, yoga?
Or Indian driving?
Indian driving, oh no, there are no questions about it. You drive wherever you can find space. You see, left and right are human constructs in the mind. If you have any questions on nirvana, marijuana, feel free to ask. No questions? All right. Sorry? Selling some. Well, I'll take you to that state where you can go without marijuana. Yeah? The fees is only $1,000 after this session. I hope you have that kind of cash with you.
So is it your presentation?
Yes. Thank you so much. This is the clicker, right?
Is
Yeah.
it on?
Perfect.
Can you check whether you can list it? Slide in. Okay.
Yeah, does work. Shall I start now? Excellent. Before I start, my friends, I'll start not with a Russian greeting, but with a Hindu greeting. Namaste. And this greeting, what does it mean? It means the divinity inside me greets the divinity inside you. Whether you believe in God or not, that doesn't matter. Right now, we are one, and I would say with feeling from here, a greeting from here to here for you once again, and then we will start. I don't know if you felt that love coming out of my heart. I need to work on it then. Yes, now you can close the doors, and I have posted people outside the doors. You are not allowed to go out. When will you be allowed to go out? After paying 1,000 rubles. Coming in was your choice, going out is money choice. Also, one good thing, they don't have a calendar here. I don't speak by minutes, I speak by calendar days. I hope you have informed people in your family that you won't be coming home today.
Make us a help.
Yeah? That's a suggestion, I will ignore it. Let's begin. Welcome. What you're seeing right now is hardened light. This is not a human being. This is hardened light beamed here, because this world is now right now controlled by an AI sitting many thousand light years away. Yes? Many thousand light years away, an artificial intelligence. Is that what we are going to talk about here? What is the meaning of artificial intelligence? Are we really there? Is AI going to take over the world? Forget about the word. Is AI going to take over my job That's the most important thing. How many of you think that in near future, AI is going to take over your job? Raise your hands, please. Nobody. Very good to see at least a few hands, because if you're not thinking from that perspective, you are probably missing out on some things. Be afraid, really afraid that machines are coming to take away your jobs. Yeah? All right. If you're not afraid, maybe I have not been menacing enough. I told you I'm an AI. This is what we are going to talk about. How many of you have worked testing systems which utilize artificial intelligence? Raise your hands, please. Okay. Thank you. What I'm going to do is take you through some basics of artificial intelligence. That's the first half. Second half, I'm going to talk about how to test and where all can we use AI in testing. Okay? What is AI? You can read the definition as well as I can, so I'm not going to read the slide out for you. Read the first 2 lines, that's good enough. Solving a problem in more human-like fashion. Yeah? That means when we solve a problem, we have a greenhouse issue, we have overpopulation issue, we have pollution issue. That's how human beings solve problems now. So what is it that we are talking about? When we say AI more human-like fashion, are we talking about machines actually thinking, actually doing something like humans? Which humans? So that's the question. I would say for the moment, let's distinguish between fact and fiction, and there are 2 different types of AIs, narrow and general AI. Narrow AI focused on solving one problem. So there's no true intelligence behind it. It just solves one particular problem. For example, you develop a program to play games. Can that program also drive your car? Probably no. Manage your calendar? Probably no. So that is narrow AI. It's still, I don't really like to use the word AI for such things, but that's how the word goes about doing it. So we call it AI, but narrow AI. General AI, an AI is able to do tasks that a typical human can do. Can you learn new tasks? Yes or no? Yes. That means those who are silent, they cannot learn new tasks. I'll force you to respond by making insults like these. Tell me, can you learn new tasks?
Yes, sure.
Thank you. If you can learn new tasks and you expect your artificial intelligence to learn new tasks, you would be disappointed, at least today. That AI, conscious AI, is still not there, and we don't know what will happen when that becomes a reality. We also don't know how far in the future that will become a reality. So right now you can rest assured not all your jobs are going to go away till the time we have this. And when we have super AI, what will happen? No idea. Will we get there? Revolution probably would happen here as well. Here it would be a much bigger thing than revolution if you have a word for it. Word domination. Well, AI is not something new. People have been doing AI since 1950s and so on. It doesn't matter to us. The slide is there just to tell you AI is not something new. Different approaches have been used. In 1980s, a lot of my peers went into PhD trying to do neural networks and AI, and they told me I should join them. I was in software industry, doing very well, earning lots of money, and those guys, they had no jobs. They were, or very less paying jobs. I thought I'm a happy guy, wise guy. I have made a lot of money, other people are struggling with something that is not becoming a reality. Today, those PhDs, they are in very hot demand. They can name their price and companies will pick them up. So I don't know whether I was smart or I was stupid. It's come full circle. Now I'm planning to enroll in a PhD. Do you need a PhD? Do you need a PhD to learn about AI and to test AI? Probably not. But just to give you an idea of where we are, you must have heard words like deep learning, machine learning. So AI is a larger set, of which achieving AI through machine learning is the current thing that we are talking about. So you should not get confused. AI with machine learning is the trend or flavor of the month or the decade. And deep learning is something that utilizes neural nets, a more specific part of machine learning. So this is the relationship. Should you ask yourself, should I go for AI? Should I go about learning machine learning or deep learning and so on? So maybe you start this way and this happens automatically. AI, the tools, products, utilizing AI, huge number. It's all around you. So don't think it is not there. It's very much there. You can look at the links later to see where I picked up this diagram from. But some of the known applications, you use AI every day. How many of you use Gmail and now it auto-completes your sentences? That is an example of AI, right? Search, whenever it gives you suggestions, or you use Amazon or any of those Netflix, etc., and gives you recommendations, that's AI. So AI is everywhere. So we'll not go much there. But if I want to be an AI professional, I'm not saying AI tester, I'm saying AI professionals, what are the kind of skills do I need? Statistics, mathematics, programming, latest technology, some of the programming languages and the libraries that go with them, and so on and so forth. But how do I become a good AI tester is the question that hasn't been answered deeply so far. And we are working on creating that answer. In 2 hours, I cannot give you that answer. In one day, I cannot give you that answer. A lot of work is happening today as we speak about how to do testing in AI. Nobody has really got a full, complete answer with a set of tools, methods, methodologies, technology, which will help you do all this that I'm going to talk about. That means you have to build your own tools. You have to make do with what exists today, and maybe you will get some ideas about creating products in the AI space that will help people. And if you make a company, if you create a company, have a product which becomes hugely successful, you make more money than anybody in the world has made, don't forget me, 10% of that company should belong to me. So let's look at AI fundamentals first. I'm not going to go too deep into it, but you need to understand a bit on what exactly is involved in machine learning and how we make use of that. Any idea what is machine learning? The name is very simple, machine learning. A machine learns something, correct? How does it learn? How did you learn? By listening?
Based on experience.
Based on experience, new information, but how did you learn? Somebody taught you, correct? Somebody taught you. Somebody taught you the alphabet. Somebody taught you to create words. Somebody taught you to create sentences, read, understand, appreciate, and so on. In a similar way, we have learning which comes through somebody teaching the machine, and that is known as supervised or directed learning. Then there is learning which is unsupervised, undirected. For example, how many of you speak at least 2 languages? How did you learn your second language? Just by listening? Or were you taught in a very formal way? You were taught in a formal way? How did you learn your first language? Were you taught the grammar of the language first and then you learned? How did you learn? You heard, right? As a child, you heard, and when you heard, you spoke and you were guided in speaking, correct? Can you tell if I speak a grammatically incorrect sentence in Russian, would you be able to tell me that? Even if you don't know the grammar? Yes, you would be. Even if you don't study grammar, you would say this sentence is done in an incorrect way, isn't it? You don't know what rule of grammar it really breaks, but you know it is wrong. For example, in English, if I said, he did went, you would say this is incorrect, even if you don't know why it is incorrect. Now that is, in a sense, unsupervised learning, meaning your brain formed certain rules of its own and classified things as right and wrong and so on. So loosely speaking, this is unsupervised learning, and we'll get there, don't worry. And then of course there are other things which some of them I will cover. So first let's look at supervised learning. The model, so there's a model. One important thing in AI and machine learning to understand is it is not program driven. Usually we are used to seeing everything as if then else, correct? You have a program which says if this is the situation, do this, otherwise do that. And the answer of a test case is usually pass or fail, because either it matches the expectation or it doesn't match the expectation. Is that correct? That being the case, let's come back here for a moment. There's a model and you feed the data into the model. The model gives you the output, and depending on how much data and what type of data have you fed it, the output could be different actually, meaning the program doesn't change. It is the data that shapes the behavior of the program, and this is fundamentally different than your procedural or object-oriented programming languages that you use to create your traditional program. The languages still are the same, but the way the program gives its output depends not on the programming constructs that you have used, but on the model that has been created and how it has learned. So you give data to the system and you say this is the expected output, and the system says okay, and then you give some more data and says for this data this is the expected output, and the system fine-tunes itself to get the output that you want it to get. This is known as training. Something like you train your dog. Pavlov's experiment, I'm sure you would know that. In a sense it's similar. And now once you have trained your model, you need to test it. Does it work okay? And once you have tested it, what do you expect? That I give it data and it will produce the correct output for me. Unfortunately, correct output in this case does not mean a yes or a no kind of a thing most of the times. There's a probability associated with it. So that is what we testers need to understand, that it is not 0 and 100%. It could be various probabilities between 0 to 100%. We will see it a little later when I give you a practical example in second half, then probably what I'm saying will become more clear. The whole idea is that the algorithm or the model should be able to generalize. You taught something specific here, the algorithm should be able to generalize, and whatever input you want to give to it, it should be able to produce an expected output with some level of accuracy. So what kind of outputs do I expect? Let's take a look at them. The first output, sort of classification. This is my input space. My output should be able to classify that in 1, 2, 5, 10, whatever number of classifiers I may have. For example, is this mail spam or not spam? Traditionally, the way you did things was you wrote certain set of rules. If those rules are satisfied, a mail would be marked as spam, otherwise not. But now the system learns. It's not just a simple set of if then else rules that are there. The system learns and then it labels apples and oranges. Patient diagnosis. Is it cancer? Is it not? You give a scan to the algorithm. Is it a tumor or not? The idea is that what human eyes can discern, a computer probably can do better, and if it has been trained well, chances are that it will actually be able to detect things much better than human beings. Now, this is known as a supervised learning classification problem. Don't worry about the algorithms that are being used. These slides are here for your reference. Should you really want to get deeper into it, you can take a look at some of these algorithms. So, are we clear about what classification problem is? How does that work? Supply input, supply output, train the model, test the model, then supply it with real world data. You get output with certain level of accuracy. You say this level of accuracy is good enough for me. Yeah? Then the second problem is regression problem, and here I have to warn you. The word regression brings shudders into everybody's heart. You think you are releasing a product in the field and you have regression problems. Unfortunately, this word regression has nothing to do with regression as we testers understand it. Okay? So, wipe that definition of regression off when you want to learn this. The whole idea here is you give certain set of inputs and the output is a continuous quantity. It could be a number. For example, you want to predict how many people are going to attend SQA 25. This one is 24 based on your interest and interviews and so on and so forth. You want to predict that. Now, that is kind of regression that we are talking about. Okay? Typically used for predicting sales and pricing and so on and so forth. Then there is unsupervised learning, and this is a very interesting learning. Data. You have huge amount of data available. Have you ever asked a question, what is it that has given rise to artificial intelligence in last few years, 4 years, 5 years? Have you ever thought about that? No? Data. Cloud. So, you have access to data, data is being generated by terabytes, being stored, is made available. Not even a single aspect of your life remains unexplored by people who have access to your data. They can predict your behavior better than your wives or husbands can. Husbands anyway cannot predict the behavior of wives, it's only the other way around. They are more discerning. Do you agree with me on that statement? Women are much better at reading men than the other way around. Maybe they come with inbuilt artificial intelligence of this type. Okay, so what do you do here? You just pump data into the system and the data learns by itself. What does it do? It tries to make sense of all the data that you are giving to it. There are no labels to the data. So, if there is no label, if there is no expected output, what can you really expect to learn from it? You could potentially learn that when it is minus 25 degrees in Moscow, you sell more tea in India. What is the relationship? We don't know. It is just the data which is telling you that whenever it is minus 25 degrees or 20 degrees in Moscow, somehow the sales of tea in India goes up. Now, that's interesting correlation which may or may not have any linkage between the two, but this is a pattern that has emerged after analyzing the data and the machine learning it. So, such interesting things get thrown up and sometimes they are totally useless, but many a times it actually can reveal many interesting interactions and facets. So, you see this in pattern detection and descriptive modeling. Let's look at what are different types of unsupervised learning? Well, what can you see here? Clustering. I have provided input and the machine learns and tries to provide data in a clustered fashion. They all belong together, and so it's able to do that. So it's done on the basis of statistical properties of the input, and the example uses image segmentation, customer segmentation, portfolio analysis, social network analysis, and so on. So when you have vast data, but you don't have expected outputs associated with them, you use unstructured learning. Just one thing you should remember, labeling data is very expensive. Go to social media and look at your posts, Twitter posts, Instagram, Facebook, whatever you use. Do you label the data and say, oh, this is a joke that I have posted? Do you ever do that? No. The software has to make sense of it. This is political satire, this is terrorism, this is a joke, and so on and so forth. So if you want somebody to label the data, it's human beings to do that. It's an expensive affair, but sometimes you need to do that. A few weeks ago, somebody contacted my company saying, we have this huge database of images, terabytes. We want at least 50 people looking at the image and identifying human beings and animals in it. They were trying to train their AI algorithm so that whenever they see an animal or a human face in an image, they would be able to tag it and say human being or animal. Now they were trying to do structured learning, but this is unsupervised learning, okay? Then there is unsupervised learning called as association, where you discover patterns or relationships in the data. For example, recommendation engines. Have you seen any recommendation thrown to you when you used any of the e-commerce website or Netflix or whatever equivalent of that you have here and so on? It tells you, oh, you may want to watch this, you may want to read this. How accurate are those things? Right now, recommendation engines are in their infancy. They just take a look at what you're doing and throw similar stuff. Mind you, that similar stuff may or may not have been classified. So it's a difficult exercise. And if you want to make a fool of recommendation engine, you can actually watch 1 or 2 or 3 things of a different genre, of a different style, and immediately the suggestions would change and would start going towards that. Does that really reflect a temporary blip in what you want to read, or is it really a trend? That is the question, and the algorithms today, they don't get it right. But there's a lot of scope here, but the question is, as a tester, how do I know that what has been recommended is good or bad? Do you see the problem? There's no correct answer here, that if you watch Star Wars, all 6 episodes, one after another, or the Matrix 1, 2, and 3, does it mean that you are interested only in science fiction? Should my next recommendation be on science fiction, or should it be on the basis of 10 years of data that I have collected on you? So those are the questions that have to be dealt with by unsupervised learning programs. Okay? Then there is semi-supervised learning, provides some labeled data, some unlabeled data, and so on. Okay? Then there is reinforcement learning, very important, because you learn, or your algorithm or your model is learning from what you are doing. Okay? Anything new? Anything that needs explanation? How do you do it? How do you learn from your experience? So typically a reward cycle is used. If right thing, it gets rewarded, wrong thing, it gets penalized. After many iterations, everything happens okay. For example, this is used in playing games. I've not taken many examples here because I wanted to give you more information, but this is an example I need to take. How many of you have heard of a game called chess? Human beings were defeated long time ago by computers. Kasparov was the first world champion who got defeated by the computer. Long time back, Deep Blue was the IBM machine, correct? How many of you have heard of Go? A game orders of magnitude more complex than chess. And an AI and a computer game defeated world's Go champion very easily and interesting. So this was a computer, this was a program which was made specifically to play Go. And few years later, they made a general program which could learn to play any game, and in 3 days it learned not only to play game, Go, but it also defeated the other computer program, the previous one. So imagine machines are now playing against machines and defeating machines. Just 3 days it took. Now that's a very interesting thing, isn't it? Some of these games, they actually make use of reinforcement learning. Every time you do a wrong move, you are penalized. Every time you do a right move, you're given a thumbs up. You accumulate enough likes or thumbs up, and you know how to play the game. Okay? Then there is something called as artificial neural networks. Some of these, especially deep learning concepts, make use of neural nets done in 1980s. You try to mimic how neurons work, and you provide inputs to the neurons, add weights to certain parts, and then this keeps learning, and a neuron gets triggered only if it gets an input of certain intensity, which depends on the weights that have been provided here. And you can have multiple layers. The more layers you have, harder it is to train, takes more time, but better it is. So more complex, but then it becomes very difficult to understand what the output was, why was that the output. Is that really important? Do we really need to understand why the output that was produced was produced? What do you say? You get an output, you're happy with it, isn't it? Well, soon you will see you cannot be happy with the output that you got, and why I will explain. But just 4 terms I would want to tell you, and that will probably more or less cover the basics of artificial intelligence with machine learning. All of you understand structured and unstructured data? Yeah? When I have a format, predefined format, that's structured data, always unambiguous. Unstructured data, no structure. And no structure. Can you give me examples of unstructured data? Yes? Go ahead. An example?
Examples. Okay. Its example is like you say, it's based on the people or something creative or like
right.
music and,
like music, sure. Your posts on social media, tweets, and so on and so forth. Most of the data on the world out there is unstructured data. Why is this important? Because you have to understand what is the model expecting, structured data or unstructured data. And sometimes you have to convert unstructured data into structured data and so on. So that means effort on the side of people who are dealing with AI, which means an effort also for the testers. So it is important to understand that part. Now typically what you do is, you have a model and you train the model. How many of you have dogs? I thought, with Pavlov being from here, everybody in Russia would have a dog. When you have a dog and you give some command to the dog, if you are teaching the dog and the dog does that and you reward the dog, you say, my dog can actually do somersaults. And your guest would say, show me. So far what you've done is training. And after that you give the command, you're actually testing your dog. right? So this is what this is all about. First, you have a model, feed the data, train it, and then test it. There are a lot of algorithms or I would say techniques that have been created to say how am I going to test my model. But this is only at a programmer's level or a level of a person who has created that algorithm and wants to test whether that algorithm works okay or not, the model works okay or not, and so on. Okay? So when you test it, you find that while the model was working on the trained data, on the training data, model was giving me 85% accurate results. And when I use my test data, it gives me 90% correct results or 70% correct results. So if it is giving you less correct results, you say maybe my training is not so good. I need to train my model further because I need minimum 90% accuracy. So you train it further till the time your training data accuracy is 90%, and then you test it. Now the interesting thing is that you have to figure out, if I test it and I get certain accuracy, and the difference between trained data accuracy and test data accuracy or the behavior of the application, is it good enough or not? So this is your data which is underfitted data, meaning you had a lot of data, but your model, when you train it, it doesn't fit. So let's say the accuracy is only 60%, you say it's underfitting. This is good fitting, where you say if I get 90% accuracy, I'm okay. So this is good fit or robust fit. You say no, I want 100% while training, 100% accuracy. You see the kind of curve that has been fitted, 100% accurate. But don't you think it's a very special case? I may have jumped through 10 hoops, did 50 somersaults to achieve this. Consequently, when you have overfitted data, chances are that when it goes in the field and you give it actual data, the results are going to be horrendous. So your data, when you train your system, it shouldn't be underfitted, it shouldn't be overfitted. You need to look at good fit or robust fit. Unfortunately, there is no clear-cut answer to what is robust or good fit. It depends from situation to situation. Sometimes 70% may be okay, and sometimes 99% may not be okay. Are we good so far? How much time do I have? Plenty of time. 15 minutes. 15 minutes I can finish the presentation. Then you can go and take a walk and meet Putin maybe in the Kremlin and come back by that time. What does this say? AI, what's the next word? Testing. What's the next word? AI. What does it mean? It's like a circle. AI, so you use AI to do testing. You create testing programs, algorithms which are AI driven, right? And then you use them to test AI. And then you use that and feed it back, so it becomes self-perpetuating loop. And your AI is testing AI, and your AI testing is testing the AI that you have produced. Mind-numbing, right? The improvement can happen automatically. But right now, that's not what I'm going to talk about. I'm going to talk about how can you use AI in testing. There's a second problem, which is how to test AI. I will talk about how to test AI in the second half. In this half, I'm going to talk about how do you use AI in testing. Anybody has any idea? Anybody has done that kind of work? Here, those who have used AI? First benchers, how do you use AI in testing? Use of artificial intelligence to test better. Go ahead, you speak, I will rephrase.
Maybe we can predict user cases and test our example.
Okay.
Yeah,
So Please tell me if I have misphrased you. What he said was, you can look at use cases, how users are going to use a particular product, and have your tests mimic those so that the user flows and workflows, etc., can be tested. So it helps you get rid of those pesky business analysts who tell you how the users are going to use it. Yeah? Okay, that's one way. Anybody else? Yes?
For the data preparation and data analysis.
For data preparation and data analysis. Excellent. How? How can you use AI for data preparation and analysis? Your AI program learns what your program needs as data input, what is right data, wrong data, clean data, unclean data, and so on. And how many of you use some techniques to scrub the data of personal information? AI can help with that, removing, for example, identifying things like social security numbers, credit card numbers, salaries, right? I had this very interesting experience or example of a company scrubbing their data. So they took their company payroll, replaced all the names of the people with other names, and used that for their testing. And immediately, everybody knew how much money the CEO is making, because that was the highest figure. They changed the name, but the amount of money that was being paid was highest, and they knew what is the salary of the CEO. So you have to be very careful when you scrub your data. You don't leave telltale marks. AI can be very helpful in such activities. Anything else? Where would you like to use AI? Well, I would like AI to test for me so that I sit at home, watch football, AI does my work, I get the salary. Is that okay? Yeah, maybe. So let's talk about that. But first, let's look at functional testing. Can AI help me do testing? Tell me. What do you think? Yes?
Maybe AI can create, finds always in functional and finds negative scenarios.
Okay.
Very hard to understand.
So what he said was that can find out positive and negative scenarios. So what do we do in functional testing? We understand how the system works. We try to create tests for those. If you are following exploratory or agile, maybe you don't write test cases, otherwise you write test cases, correct? You review them. Can all of these things be done by AI? It looked like a dream a few years ago, but today some part of that can be done by AI, and tomorrow a lot of part of that would be possible using AI. Just think, how many applications in the world use a user ID and a password as a basic authentication mechanism? Almost every application worth its salt, correct? Yes or no? What kind of test cases do you have for this kind of functional testing? These are pretty standard test cases. Based on your system, how many characters password, what are the password policies, where are the passwords stored, are they encrypted, not encrypted, how can they be reset, and so on, correct? And AI can actually pick up all of these things from a large number of applications. This is unsupervised learning. You run your tool on a lot of applications, and they learn everything that is to be learned about login testing. And then you let loose this application on a new program. It sees a user ID and a password button. It has all the information about various ways this can work, and it tries to give the data, observe the responses, and say pass or fail. Where is a human tester there? Where are you? This is possible today. In fact, some of the tools do that. What I'm saying is, now it's time to open the eyes and smell the coffee. A lot of things we think only human beings can do are actually possible today and are implemented in some of the tools today. Okay? User interface testing, automation. Why can't AI do automation? Can it? Yes, it can. AI in defect analysis and prediction. Now, this is very interesting. A lot of companies are working on this internally to create internal products. What do? They look at your defects. They look at the patterns of the defects. What are the systems in which, or what are the components and modules in which these defects are arising? What kind of fixes are required for these defects? And based on that, they learn, and then they go and look at the code and can tell you where the next defect is likely to occur. What I said about look into the code, some of the applications have started looking into it. This is a presentation I made 6 years ago or 7 years ago, that this is going to happen. I said maybe 10 to 15 years from now, but it happened much faster. Defect analysis and prediction. And of course, AI to test AI. After that, human beings are not required on this earth. What kind of tools exist? Visual automated UI testing. How many of you have used image comparison as part of automation? And did you find it useful? Did you find it very useful, or you wanted some changes to it? Now, instead of doing a pixel comparison, if my comparison utility has intelligence built into it so that it can differentiate between things, I can actually have very good output comparison and pass and fail based on that. So, instead of using pixel comparison, I use image processing technology and so on. Then GUI testing, very interesting thing. Tell me, when you learn an application for the first time, what do? Forget that you have any requirements document. There's nothing, you are given an application, how would you learn how it works? Sorry? Try everything. Yeah, good. How does try everything work? Any idea how does try everything work? First screen, you see something, you click there, next screen comes up, you try to understand what it is, click somewhere, and so on. Isn't it? Now, if you were to do it in a methodical manner, you could do it manually. You could actually take screenshots of every screen and the path it followed, and you would soon have user scenarios. Correct? Laid out visually with set of screens, nothing but a visual test case. Correct? Have you heard about visual test cases? Instead of writing down, click here, do this, do that, if I just give screenshots, any tester can pick that up and execute it. Problem is, they get outdated very easily. Second, may take a little more effort than writing a test case, because you have to mark certain things on the screen and so on. But now with AI, you can do it. You let loose the AI, the same type of programs that learn how to play a game. Can't they learn how to play your application? If these programs already exist, what prevents somebody to take similar approach to your application? And you let loose that program on your application, it tries to explore everything, and with reinforced learning, what is right and what is wrong, it knows that, in this case, I get an error message, it's a negative test case. This is something that a user does, a positive test case, and it learns from it. You give it the next version, and you can tell it, try the negative test, try the positive test, and the AI learns from it and does it. So the technology exists, and there are certain tools that exist. And the AI will then not only tell you what has changed and what is wrong or what is right, it can actually look into various other non-functional parameters as well. For example, last time when I used this software, last build, it took me X seconds to do this workflow, it's taking me Y seconds. This is within the parameter, I ignore it. If this goes beyond certain limit, it can be a trigger that something wrong has happened, right? So then of course API testing. How many of you do API testing of web services, microservices? Becoming very, very popular, especially with DevOps and microservices architecture and so on. AI can do this very easily. Then coverage analysis. How many of you have done coverage analysis of the regression test that you run? How much percentage of code does your regression test cover? Have you ever asked this question? Yes? How much? When you did it for the first time, how much did it cover?
5%.
5%? In your case? 30%? Anybody else has experience like that? Imagine you are running your regression test and only 30% of your code is getting covered. Is this good or bad? Would you call this regression testing effective or ineffective? Today we don't know if we don't run this kind of a thing. Can AI do this for us? Yes, of course it can. And it can then suggest the tests to be run so that you get more coverage. More coverage, of course, doesn't mean always better testing, but what it means is that at least you are not missing out some things. So that's a very interesting thing that can happen with coverage analysis. I'll give you a 2-minute example of something that I did before the AI days. There was a company who wanted us to test their coverage and suggest what do we need to do to improve things. They said we've been to every company, none has taken up the challenge, and I, being an idiot, I said, okay, it's a challenge, I will take it up. How much money will you pay us? The regular. Okay, it doesn't matter, the challenge is reward in itself. When do you want to finish it? 1 month from now. Okay, give us these tools. Sorry, we don't have budget for tools. Okay, that's another part of challenge. So we wrote a tool, we ran our tool on their software, the entire regression suite of some 300 plus test cases, and we found out coverage, and they had given us a mandate 95% plus coverage for critical modules, 85% plus coverage for non-critical modules. We found the coverage was between 43 to 45%. So we sat with the developers, we tried to understand why this is not getting covered, how can I cover it? If there are 5 test cases that apparently cover the same lines of tests, can I remove all of them and replace them with only 1 test case? In some cases that was possible, in other cases it was not possible because of some reasons and rules and so on. Finally, in 1 month, we wrote maybe 70, 80 new test cases, removed a large number of 170 plus test cases and reduced the regression bucket. But it took us more than a month. And finally, we were very happy we have done it. And then I realized that this company actually was going to be sold to Oracle, who were paying them a huge amount of money, but they wanted this conformance that 95% of the code is getting covered. And then if I knew it, I could have asked them 4 times the price and I would have got it. You don't need artificial intelligence for knowing that. Okay? So coverage, if I had such a tool, it would probably be a matter of a few days to finish this whole exercise, and those tools are now becoming popular. So we are going to be talking of, last thing here, automation. There are a lot of possible tools here which do automation all in a different way. I'll give you names of some of the tools, AI tools that exist today. How useful they are, you'll have to evaluate. They are in the first stage of evolution, but interesting times ahead. Once we come back from our break, which is going to be 15 minutes break, I'm going to talk now I'm going to talk about testing. I'm going to take very interesting examples of AI and how AI made mistakes and how you as a tester can do things to avoid those mistakes and test in a better way. All right? 15 minutes, maybe 17 minutes from now, we meet again, hopefully. May I ask you a non-testing related question? No? One person says no. Anybody else says yes? All right. I have a question related to use of mobiles. Today, whenever we are free, we are always looking for information, looking for messages from people we know, and so on. How much time do you think it leaves us for introspection? Are you doing less introspection today than you were doing, say, 5 or 10 years ago? Just a question. Nothing good or bad about it. Thinking about things, doing deeper thinking, like purpose of life, why am I alive, why do I live, does God exist? None of those questions bother you? Just curious to know. Yeah?
It depends on man.
Okay. But do you think use of mobiles has taken away some of that time?
You know that the attention span of mankind has decreased to the level below a goldfish.
Oh, is that so?
Mobile phones, yeah.
Wow.
It has dropped from 24 seconds to 9 seconds attention span. That's the maximum.
So if you did not hear, what he said was attention span of mankind has dropped from 24 seconds to 9 seconds, which is less than that of a goldfish. Okay. So plasticity of brain and, so okay, it's interesting. Why did I ask that question? That question I can ask, right? Why did I ask that question? What was that? What did I do?
You can start. And you have a presentation.
No. Was it something that I did? I'll try to stay still. Are we good to go now? Okay. So I'm just going to put some questions for you. I'm not going to go through all these questions, just ask 1 or 2 questions. How do we know what is the algorithm doing? Is the model working correctly? How do we test it? And this is a big area of research right now. And we hope to find answers as time goes by. Do you understand this word corner cases? A lot of people in AI world use this word. A lot of people in the development world use this. Essentially, in a sense, boundary values. Okay? Developers don't know the word boundary values. They use the word corner cases. In AI testing, these are very important, and we will see soon. Rest of the questions, you can take a look at them later, should you get into the field of AI testing. But let's first learn by examples. Okay? It's a very famous example. What do you see on the screen here? What do you see here? A dog or a wolf? And this one? So a program was fed images of wolf and huskies, and it was asked to recognize wolves and huskies. What could the reason be? Okay, thank you. Or maybe you can come and help me. That works okay? Thank you. Okay. So they showed a lot of images of wolves and huskies to this program, and finally it was able to identify the wolves from the huskies. And then they fed this image and it said it's a husky. It's a wolf. No, it's a husky. The program insists that it is a husky. Finally, when they went into the model and tried to figure out why it is saying so, all the images they had fed earlier to the program for training and testing purpose had wolves with snow as the background and huskies with the green forest background. And then they gave an image of a wolf with a green background, and it ignored the image of the wolf completely, focused only on the background. So what appeared to work correctly, it was producing correct results, right? But it actually was not working correctly. How do you know as a tester that this is doing okay? Imagine, huskies are friendly, right? Imagine you are running this program on a, in your house, you're living in woods, and your program alerts you to wolves. It fails to alert you to wolf. Becomes a problem, isn't it? A big problem. So the question is, if such is a program, how do I as a tester test it and verify that this is working okay? This is the challenge in testing of applications that use AI. Okay? So there is something called as LIME. There are many ways. So how does the AI work? There is a model, and that model produces certain results. And many a times you don't know what that model is doing, so you need to test that model. You need to be able to explain what the model is doing. And for that, there are a number of model agnostic methods available. LIME is one of them, one of the most popular ones. What do you see here? And? So when I asked you, what do you see here? What was the answer? Frog. Well, heart is also there. Correct? Why didn't you say there's a heart as well? How would the machine know that it has to recognize the frog and not the heart? Well, of course there's a heart here. Anything else that you see here? Yeah, background. What are these? Fingers. Do they look like fingers? Could they be construed as something else? The eyes. Could they be construed as, for example, a football? Or some sort of sphere? Or a button? What should the AI really do with this? That is essentially the question. And what LIME does is, it takes your, for example, data, divides it into many random areas, removes some of the areas, like you see here, say, can it really understand? Can it really understand what's going on? Can it really understand what's going on? And the output of this will not be one thing, but it might be a number of probabilities. Probability that it is a frog is X%, probability that it's a football is Y%, probability that it's a set of atoms being shown is another %, and that it is a heart is yet another %, and so on. Ideally, what would you say for this image? If it is identified as a frog, the probability should be as high as possible. The identification of heart, should it be less or more than identification of a frog? Equal, ideally, because there is a heart as well. And the results of the images that you feed to the system are these probabilities, and you have to figure out if this is okay. In some cases, as I said, less than 90% may not make sense. In some cases, it has to be more than 99% and so on, or 99%, whatever. So there are a few other methods. The problem is the nature of the model. Can I open it and look at it in a white box manner rather than a black box manner. Black box is easy. You give inputs, you observe the output, and you decide whether this is okay or not. And definitely that's one way to test AI, a required way. But what I need are methods by which, how many of you have heard of the Oracle problem? Oracle? What's Oracle? A company? A database? What else? Sorry? Java. Okay. Anything else? How do you know that output of this particular test case should be this, whatever it is? How do you know? So you need to have an oracle to predict the output of a test case. For example, your requirements. They tell you if you do this, this should be the outcome. So your requirements become an oracle. If I ask you to multiply two 10-digit numbers, 935 784 61 into 99102 33313, what will be the result? Can you tell me? And when your system produces that result, how do you know that that is correct? If it is 2 into 3, easy. You expect 5? No? You expect something else for 2 into 3? Okay, 6. How about a 3-digit number with a 3-digit number? How about a 10-digit number? You see the problem? I don't know the exact result that I am going to get, and for that I need an oracle. So I could have a calculator. Using the calculator, I do this multiplication, check the result of the calculator with my program, and if they are both good, match, I say test case pass. Correct? What if I don't have a calculator? What if the result is not a multiplication but an n-degree equation which is going to calculate the path of the rocket which is going to go from here to Alpha Centauri? You have no such calculator which will give you the result. How do you know that the result is okay? So one of the models that is used is surrogate models as an oracle. You create a simple system. You create a system which may take more time or less time, but which is simple, easy to do, and you feed your inputs both to your test system and to your surrogate system, and you compare the result. So that's how you do. So the developers give you an AI model, an AI program, and you use that. But then you create your own very simple algorithm based program, and you give your inputs to that as well, and you train them both so that they start matching each other. After that, you give your inputs, you get the output from your surrogate model, you compare it against your real thing. That's what you try to do here. Similarly, feature importance and so on doesn't matter right now. The thing is, in AI, you need a lot of different mechanisms to figure out what your model is doing, and if you cannot figure that out, you cannot guarantee that what is happening is okay. Just to give you one more example, at the metro station in one of the countries, they had this problem of peak hour traffic. I guess you don't have that problem here. They taught a machine to open more gates when there was a lot of traffic. So what did they do to do it? They took video of a lot of different times when the platform was empty and when platform was full of people, and taught it to open the gates when there is crowd. So when there is more crowd, more number of gates are available. When there is less crowd, there are less number of gates that are available. Everything was working okay, and they patted themselves on the back. Everything is good. We have used an AI system. We are one of the most advanced metro station in the world. And then one holiday, they found there was nobody on the platform, almost nobody, but there were a large number of gates which were open. So they were wondering, what has happened? And so they went into the model, tried to look into it. Imagine what did they find? they found that in the video, on the wall, there was a clock. The model ignored the faces of the people completely. It said 8 to 10, the gates should be open, and that was it. A simple program could have done that, right? And so it didn't care. 8 to 10, Monday to Friday, let's open the more gates. Saturday, Sunday, let's keep it closed. And then one Tuesday, when it was a holiday, because it was my birthday, they opened a lot of gates. And now as a tester of such a system, how would you ensure that it has learned everything correctly? That it is not working because of a chance or a fluke or a totally unrelated parameter. So that's the challenge we testers face, and many of these methods which can help you explain the model, you use these methods, play with the model and try to figure out what is that particular factor or feature which is causing the model to behave in this way, and you change that feature, and if the system output remains the same, that means that feature is not important in determining the output, and you remove that feature and your output changes drastically, you know that this is one of the most important feature or factor in output of this particular model. So what does it mean? You say, okay, it's not the feature. Which feature? Time of the clock. That's not important. That is not what I'm interested in. And so then you go back to your algorithm, you remove that feature, you say that this feature has less weight, so consequently time is considered as less weight, whereas number of people and the faces that you detect, that is given more importance, more weight, and your algorithm is fine-tuned in this way. And this is your job as a tester, to think of large number of scenarios and corner cases that you can feed into the system for training as well as for testing. Okay? So please read these 4 bullet points. Can we understand what the machine learning algorithm is doing? And can I compare different machine learning algorithms? Can I improve the existing machine learning algorithm? And can we predict how machine learning will behave on new data? And the whole research on testing is mostly focused on these 4 questions today for AI and testing. And you can continue to use your black box methods and gray box methods to do this. So the good news is, as testers, you have no danger of being irrelevant, as long as you can think very smartly. Okay? How? I will talk to you in a moment. How many of you are aware of this accident of a self-driving car? Raise your hands, please. Quite a number of you. Do you know the story behind it? And then the next question is, if you were testing this system, what would you do things in a different way? How would you test it? What kind of test cases would you create? So let's first look at the accident. Uber had this self-driving car. A woman was sitting in it. There was actually a human operator also sitting there who was not driving the car but observing the road and had final say in saying whether the car is going to stop or not or do what. And it was doing about 60 kilometers an hour, and out came a lady walking her bike across a street perpendicular to the car. Ideally, in a self-driving car, what would you expect? It would recognize that there is a person, there is an obstacle, even if not a person, and stop the car at safe distance. The car, unfortunately, killed the woman in a collision. So first reaction people had was, oh, this is a bad system. The car probably didn't see the woman at all, or if it saw the woman, it probably didn't recognize the woman as something for which the car should stop. For example, it could just be a shadow. Do you want your car to stop because of a shadow? Now that's a kind of scenario you have to really look out for. and a car has to recognize a person as a person, not a shadow as a person, or a person as a shadow. So, finally, when they did their forensics and analysis, they found out that the car had radar and lidar sensors. They had detected 6 seconds before the crash. So, there was enough time to apply the brakes. It was going to be a difficult maneuver, but still possible, and the woman would have been saved had the car applied the brakes. So, what did the system actually do? The system first identified her as an unknown object, then identified as a vehicle, and then identifying that vehicle as a bicycle, and each time adjusting expected path of travel. See, it's a complex algorithm. The whole time you have to figure out, will she stop or will she keep moving? Because my next action, if I can't brake, is to go around it. As human beings, you must have found it out how difficult it is to anticipate the reaction of the person. What if she froze? What if she ran? What if she ran in the opposite direction? So the car has to make all these adjustments all the time. But unfortunately, just a second before impact, the self-driving system determined that emergency braking maneuver was needed to mitigate a collision. So it did determine, and it could have prevented this accident. Now the question is not what happened, why did it really get into it? Because when you look at the answer, you will say, oh, it was not a software fault. But right now, I am not about whether it is a software fault or a human fault. I am saying, is this a scenario that I should have tested for when I was testing this kind of a system? Do you think I should have tested for this scenario? Somebody coming out of at an intersection from the shadows quickly. It's a very usual scenario, right? And you would say any tester who was testing this should have tested it. Well, what is your reaction when your managers come and tell you, why didn't you test it when there is a problem found in the field? And they come to you and say, but this is so obvious. This is one of the most important tests. How could you miss it? Have you ever been told such things by your managers? So you understand that if you make that statement here, you are behaving as your, I'll not take that name. Let's see what, some tests first. If you were to test a self-driving car, here are some of the tests. Applicable specifically to this scenario, just this scenario. Emerging from darkness on the side of the road. So I will do a test where visibility is poor and somebody comes quickly in your path of travel. I will do that, right? What's the second test? I need to know that if I'm using lidar, when something is perpendicular to the lidar, it's going to cause a problem. So I need to have test cases. Maybe they, how many people travel by bicycle? Depending on which country you are in, there could be quite a few people or next to none, right? Sorry? So how many images do you use to test this? How many bicycle images, how many other car images, truck images, pedestrians, dogs, cats, bale of hay, plastic, and so on and so forth. At what speed have I tested all these? Maybe all this works okay at 40 miles an hour or 60 kilometers an hour, but doesn't work well at 62 kilometers an hour. So that's an additional challenge with respect to test data. People moving erratically. Whatever I have, it moves erratically. Sudden movements. Items on bicycle like plastic or hay, which will make the AI algorithm think, oh, this is plastic, this is just a bundle of grass, this is just a shadow, and so on. Yeah? Fog causing distortion in what the camera is getting, that's also a real probability. The dress of the woman matched the road or plants or plastic bag or anything, right? Imagine Woman's face is only this much, the whole body is this much, she is wearing a dress which has many interesting patterns, which the image recognition, because it is not like human beings, it recognizes the dress as not something worn by a human being, but as something else totally, something through which I can pass by. So these are the kind of tests that you need to test for this specific scenario. How many of you will run all these different types of tests? Of course, this is not an exhaustive list, right? So can you think of the complexity involved in your thought process of what all different scenarios you will try out? Mind you, there is no requirement here that you can read and say, I will do these tests. The number of tests that you can do is infinite, limitless, and you cannot use your equivalence partitioning techniques here very easily to say that, you know, I have done 1 out of 100, so I am good. Can you? That's the big challenge for testers here. Anyway, let's see what actually happened. Uber did not allow the system, meaning the car, to make emergency braking maneuvers, the self-driving system. It disabled that. It said if emergency braking has to happen, it will be done by the human being. Okay? All right. What is human being's reaction time? Can it react in less than a second? It probably cannot. Second thing, what is human being doing at that particular point of time when such a thing happens? The person says she was looking at the instrument panel and noting down things. So her gaze, her vision was not on the road. So she did not become aware. The car had its own emergency braking system, but it was disabled by Uber, and rightly so, because you cannot have two different controllers for the same system. You cannot have two different people decide whether to engage emergency brakes or not. Human being rather than the software, but it gives you a very interesting scenario that if I were testing such a system, look at the depth of testing that I would need to do. Yep. Tell me which of the test design techniques allow you to think so widely out of box. So exploratory, but exploratory, unfortunately, despite all the names of things like tours, heuristics, what else? Mnemonics, take any name, they don't allow you to think. Of course, there are some other things like questioning, 5W1H, have you heard the name? 5W1H, what, why, where, when, who, how many, how much, and so on. That's a good way of starting to think. I'll give you another method that can be used. But before we go there, if you want to think about testing an AI system, let me give you an example. You can go home, take a look at it, and then test it. So you go to this URL, tone analyzer. What does it do? It analyzes the tone of written words, sentences. Is the person angry? Is the person happy? Why is this kind of analysis required? Sometimes companies need bots. They look at your Twitter feed, for example, and they find an angry customer. They want to respond to the customer in an appropriate way. They find a happy customer. They want to respond in an appropriate way. So analyzing the tone is very important. Also, many of the call centers use this technology. What do they do? When you are talking to the user uses some words and phrases in a particular way with a particular emotion, and on their screen comes written, user is anxious. So you know that you need to slow down, pacify the user, and so on. So it's becoming very big. So when you go to this URL, you find some sort of space where you can copy the text. You copy the text and you ask the system to analyze it. And the system then tells you what kind of sentence and tone is there in sentence and to what degree of likelihood. Now read this sentence. I am totally flummoxed. I just don't know what's happening. What is the analysis? The person is confident to, this is the probability. Do you think that's correct? If you think this is correct, think about what Bill Gates had to say. So I picked up some speech of Bill Gates, pasted it here. It said, well, it's great to be back here at Stanford. You know that Microsoft CEO went to Stanford, but I induced him to drop out. So he never got a degree from Stanford. He did get an undergraduate degree, but I still think of him as a fellow dropout. And what does it say? Tentative. It says Bill Gates is not very sure about it. Why does it say so? But I induced him to drop out and so on, right? Now clearly this is an example of misclassification. How do you test these kind of systems? You can throw large number of data at it, data for which you have to know the output, correct? Getting output of that particular data is tough. You cannot read 500 different sentences, different pages worth of sentences, put them one by one and test it. Maybe each individual sentence classifies it as one thing, but the whole paragraph classifies it as something else. So I'm leaving this exercise to you. Feel free to get in touch with me. I'll give you my email ID. If you do this exercise, come up with a strategy of how you are going to test such a system. Okay? So this particular sentence, it's saying that this is tentative, not good classification. Okay? Candy Crush. How many of you played Candy Crush? Nobody? This used to be a very addictive game on phones at one point of time. You would have candies, arranged candies of a particular color, shape, size, and it gives you points, and more candies appear. And they have levels and levels and levels, thousands of levels. It was one of the most popular games at one point of time. People started testing it. Now it was very difficult to test. So what they did was, they did a brute force technique, trying all combination. I'm saying the people who developed the game, and they found it was not working. Finally, they went to genetic algorithms, a game playing system, a system which would try out an algorithm, for example, move this candy from here to here. Oh, this doesn't work, throw it out, let's have something else. And so they would keep trying it and keep improving with every iteration, and after a few iterations, maybe 30, 40, 50 iterations, you would have a game playing algorithm which will play it to the best possible way, and that's how you would test this system. You can read more about it here. So this is an example where a conventional problem cannot be solved by conventional method, but AI can help you solve that problem. So what you can do, if you really want to understand how to test AI, for example, Facebook friend recommendation, try it out. It would be very interesting to see on what basis do they recommend friends to you. Or look at Gmail spam filtering. Create an account which is not your regular account. Go to various sites, register there and so on and so forth, and see emails coming. It would be a very interesting experiment. You want to know more about interesting cases, look at them. Especially this one, where they created a computer program which started stealing money. Imagine, you trusted a computer program to take money from your account, put it into your another account so that you can pay bills. And after 6 months when they did an audit, they found this computer program had made its own account, and every month it will steal a few dollars, euros, rubles from your account and put it in its own account. Why and how that happened? Do take a look at it. You will find it very interesting. And finally, if you want to understand how to do millions of test cases with very little requirement or no requirement, just few words, you search for extension to noun and verb on the web, you will find a technique that I developed 10 years ago. You can easily within half an hour to 1 hour generate millions of test cases. Now many of them are going to be your corner cases. You don't need to write them down, but use the technique and use this technique to create tests or test data or training data and test data for your AI application. Of course, you can use it for your day-to-day testing as well. So full presentation is available. I don't think I have put my email ID here. You want? I can give it to you. There's only one condition. You promise that you will look into these things, and if you have questions, you'll ask me. I promise you, if you ask me a question, I will take time out to reply to those. Conventional testing, AI testing, doesn't matter. That's it I had to say for today. Some other day maybe I'll give you some programs, some AI programs, some sample data, and then ask you to basically test it. If we were to do a one-day long workshop, that's what we would do. Thank you so much. Open to questions.
First part of your speech, you talked about using AI in testing. Not testing the AI, but AI in testing. So, in which kind of projects it makes sense to use it? Because it's very difficult to learn AI.
I agree. For example, this is a kind of problem. Problems where conventional methods don't work because the brute force requires you to do it at a much larger scale and takes much more time. Is the technology mature enough for you to do this? Yes. But are there tools that allow you to do without programming? No. That's the problem today. You have the technology which will do probably 70, 80, 90% of the work, but there is no existing tool in the market which will fit all your needs. So you need to have people who know how to do this programming, who are expert on AI ML, and then they can do something for you. Do I expect testers to write those programs? Today, no. 5 years down the line? Yes, because there are a lot of toolkits available out there. All you need is a bit of programming, a bit of knowledge, and the frameworks would become good enough that anybody would be able to use them. If you know programming, nothing like it. Go ahead. Any other question?
Здравствуйте. Расскажите, пожалуйста, в первой части вашего доклада вы привели пример, что шахматы, Го, искусственный интеллект. Да, хорошо.
So can somebody translate back there? I don't know if they have a mic or not, but if you can give the translators the mic. Yeah, okay. Yeah, please turn it on.
Начну еще раз сначала. Соответственно, в первой части вашего доклада вы привели пример, что искусственный интеллект
I can hear you.
выиграл у человека в Го и шахматы. Летом этого года был турнир по доте, в котором команда ботов проиграла команде людей. Одной из причин проигрыша искусственного интеллекта людям назвали, что искусственный интеллект не умеет между собой коммуницировать или взаимодействовать. Вопрос, может ли в перспективе
No, but I can't hear the translation.
научиться взаимодействовать?
I didn't hear the translation. I just heard your voice. I didn't hear the translation. Say that again. Too bad. Okay, we'll come to you. Now I can hear you. Lost again. Did you hear that? Can you translate it for me here?
Я просто, значит, почему, то есть проиграла команда компьютеров, проиграла людям, потому что компьютеры не могли с собой взаимодействовать.
Между собой люди умеют между собой взаимодействовать, выстраивать
I think in the example that you gave, computers, in a certain example, computers couldn't interact. That's why they lost a team of people, because computers couldn't interact, the people could. But in the future, will the
Machines
AIs
interact.
be able to learn to interact?
So interestingly, there were two AI programs. I think Google did that experiment, and they started talking to each other, and soon they developed their own language. and it was becoming difficult for the engineers to follow what these programs were doing, and they disconnected the two programs. Today itself, a lot of AI programs actually interact with machines. For example, your calendar, or when you ask Alexa or whoever, Siri, Alexa, and so on, they interact with each other. You might have seen that very interesting example where Alexa and Siri are talking to each other. So you make a command to Alexa to do something which invokes Siri, which actually invokes Google, and so on. So yes, short answer is computers will talk to each other. You will not even be aware of what is happening. Your doctor's appointment, your beautician appointment, all those appointments would be set up by machines talking to machines. Was that your question?
Почти.
Okay. So
В сборе информации, окей, они коммуницируют, а при принятии решений?
When they collect information, they communicate, but what about decision making?
when they set up your appointment, it's decision making, right? You are free at that time. So decision making is not really important. It's the question of, am I willing to give machines the freedom to take decisions on my behalf? That's the question. It's not a question of technology, it's a question of philosophy. Yeah? Yes.
Скажите, пожалуйста, какой язык программирования вы используете и порекомендуйте, пожалуйста, фреймворк или библиотеки?
Which programming language do you use and recommend framework and libraries?
Python and R are two very popular languages. I would, if you're comfortable with Python, I would say start with Python. It's easy. There are a lot of libraries available there, but then to each one his own, whatever choice you have from programming language point of view, feel free. Language is not important. It's the availability of examples and libraries so that you can quickly start doing things. So Python is a good enough thing.
Спасибо большое за вопросы. Время вышло. Мы сейчас выберем человека, который задал самый интересный вопрос. Could you choose the person with the best question? We had 3 questions.
So questions. I don't even remember what the questions were. And it would be unfair, so you'll have to give me a minute. I'll have to go over the questions and then I will. Yeah? Any other question that you might have while I think?
Если еще какой-то вопрос, у нас время вышло, но если еще один вопрос есть.
All those who asked me questions, please raise your hands.
Поднимите руки, пожалуйста, те, кто задавали вопрос.
Okay, 2 here I remember. What was your question?
About using artificial intelligence in testing programs, usual programs.
Okay, thanks. The aspect of AI that we did not cover here was the philosophical aspect, the ethical aspect. We covered just the technology part of it. Since she brought out that aspect, I would want to. Thank you so much, folks. And before I go, from the bottom of my heart, I will say namaste to once again to you. May this world find all the peace that you want for you.